right, in Chapter 4, we're going to be looking at demand and supply in much more detail, and we're going to be using demand and supply diagrams in order to measure a lot of interesting things that are going on in a market. And the reason why we want to measure all these additional things is to be able to measure changes, to see how consumers and producers are being affected by some different policies that governments might pass, some different laws, or how some kinds of inefficiencies in the market can be generated. So I'm going to start off this lecture with a story. And this story is going to seem a little silly, but it is the best way to try to remember what all these different things mean that we're going to be talking about and analyzing in a graph in just a minute. So let's start off with this story. Suppose I want to go to a party and I want to buy some cookies to take to this party. And I'm thinking about buying maybe 6 boxes of cookies. And I think to myself, I'm going to be buying 6 boxes of cookies. The absolute most I would be willing to pay for these cookies would be $90. Not a penny more. So if I go to the store and they had 6 boxes of cookies and somehow it's going to cost me more than $90, forget it. I'm just not going to buy them. So I'll walk to the store and $90 is the most I'm willing to pay. We'll abbreviate that WTP, willing to pay. I'll walk to the store and the cookies cost $6 per box. All right, so tell me, how much am I going to have to pay to buy these 6 boxes of cookies? Well, 6 boxes times $6 each is $36. So 6 boxes times $6 each is $36. What is the difference between the most I was willing to pay and how much I actually had to pay to get these boxes of cookies? Well, I said that I was willing to pay $90, and I said that I had to pay $36, so what's the difference? 90 minus 36. $54. Right, so $54 is the difference between what I was willing to shell out and what I actually had to shell out. Now, this $90 we were talking about, that is what in economics we call the total benefit. Total benefit. So what total benefit means is what's the most you'd be willing to pay to get this thing we're talking about. So here we're talking about 6 boxes of cookies. So this is how we measure benefits. We ask people, what's it worth to you? And the most direct, easily measurable way to measure what is it worth to you is to ask, well, what's the most you'd be willing to give up to get it? What's the most you'd be willing to pay? The $36 we call the store's total revenue. So how much am I paying to the store? And this total revenue is the amount of money that the business is going to be putting in the cash register after we hand the money to them. And we call the difference between the most I'm willing to pay and how much I had to pay consumer surplus. So when you think of consumer surplus, all it means is it's the difference between the total benefit and the total revenue, or the difference between the most you're willing to pay and what you had to pay to get something. Let's draw this first part here. Just a visual way to see what's going on so far. So it all starts with the $90, which is the most we're willing to pay, right? We call that the total benefit. Total benefit, what we're willing to pay. And we're splitting that into 2 parts. $54 and the $36 that I actually had to pay. So that's the total revenue, and the $54 is the consumer surplus. And remember, that consumer surplus, all it means is the difference between what I was willing to pay and what I had to pay. It's important because if it goes up, if that amount in consumer surplus were to go up for some reason, it means that I'm happier somehow. There's only 2 ways for consumer surplus to go up. One way would be for the amount I had to pay to go down, right? That would make the difference between what I was willing to pay and what I had to pay higher. Or another way for that consumer surplus to go up would be if somehow I was willing to pay more for what I got. Maybe what I got was more valuable or higher quality somehow, right? That would make that consumer surplus go up. In other words, consumer surplus is a way to measure how well off consumers are. And it's kind of a weird thing just by itself, but it is more clear to see. If consumer surplus goes up, consumers are happier. If it goes down, consumers are being hurt or damaged in some way. All right, well, now let's focus on that $36 in total revenue. Think about the business at this point. They have $36 in their cash register. What do they need to do with this revenue that they have earned from selling these 6 boxes of cookies? Well, the store is going to have to pay some of this money to their employees and for their materials that they use to make the cookies and package the cookies and things like that. So think about this part of the money, this first kind of cost that they have to pay, as being labor and materials costs. So in economics, we call these costs, things like labor and materials, variable costs. We call them variable costs because as this business wants to produce more cookies, they're going to have to pay more for this kind of thing. They're going to have to pay more for their workers, more for their materials, the sugar and the flour and the boxes to put the cookies in. And you can imagine some other things they would have to spend more money on in order to produce more cookies. So variable costs vary not because they change from day to day or because their costs might go up. What we mean by variable costs is today, as they produce more, they need more of those things, and so they have to spend more on them, okay? Now, the business also has other kinds of costs, and we call those costs fixed costs. And a fixed cost is anything that today does not cost them more as they produce more units. So the two most common kinds of things we want you to think about when you think about fixed costs are things like rent. So suppose this cookie producer has a store and they have to pay a certain amount of rent per week or per month for this store. It does not cost them any more when they produce more cookies. Their rent doesn't go up. Their rent doesn't go down if they produce less cookies, or even if they don't produce any cookies at all today, their rent's not going to go down. Another important cost, though, remember when we talk about the factors of production, land, labor, capital, and entrepreneurship, one of those factors, entrepreneurship, they have to be paid, and some of the profit this business makes needs to go to the entrepreneur. And there's a minimum amount of profit that you have to pay this entrepreneur, otherwise they're getting out of here. They're going to go find something else to do. So this is another part of fixed costs, is the minimum payment, the minimum amount of profit you have to give to this entrepreneur in order to keep them interested in sticking around. Otherwise, they're going to bail. So these are the two things you should think about as fixed costs: rent and the minimum payment that goes to the entrepreneur. By the way, we usually call this minimum payment you need to pay the entrepreneur, otherwise they'll bail, a normal profit, just to keep that in the back of your mind. And variable costs are things like labor and materials. But it can include anything that increases as you produce more units. Let's talk to this store owner a little bit more. Let's suppose that this store's variable costs are $27. It gets $36 for selling the cookies. It spends $27 for its workers and for the materials that go into making the cookies. And now it has how much left? $9. This $9 is what we call producer's surplus. So let's go back to our little diagram over here. This business is going to take the $36 and split it into two parts. $27 in this example are variable costs, VC, labor and materials cost, and then the difference is $9. And that difference is what we call producer's surplus. Producer surplus is what a business has left over after they pay their variable costs. Now, let's think about what this business is going to have to do with that $9 in producer surplus. Producer surplus is not the same thing as profit. This is one of the most commonly misunderstood things about this topic. People think producer surplus must be profit. But remember, there's another kind of cost we have to pay. So this producer surplus has to get split into two parts. Part of it has to go to pay fixed costs, which we haven't paid for yet. And then, after you take that $9 and you pay the fixed costs, if there's still any money left over, then and only then do you have a profit. We start off with the $90, the most the consumer is willing to pay for the cookies. They have to pay $36, and that leaves $54 as the difference between the most they were willing to pay and what they had to pay. Then the business takes the $36 that they have in the cash register in total revenue. They pay their variable costs of $27. That leaves $9 in producer surplus left over, which is not the same as profit, because this business has to pay their fixed costs, and then they might have some profit left over. Let's go graphing and see where these numbers come from a graph. So here's your handout for this lecture. Make sure you download and make sure you print it. And our first step, and this is going to be what you're going to be doing on your test. You're going to be graphing supply and demand from equations that I give you. And today's equations are for demand, P equals 24 minus 3Q, and for supply, P equals 3 plus 0.5Q. Make absolutely certain that when I give you equations to graph on the test, that you are going to be able to do this with absolutely no difficulty at all. So let's graph demand. There are a lot of ways you can graph it, like we talked about in the math review and like we've done in some other situations. But the most straightforward way is to look at that y-intercept of 24, and that tells you that when the quantity is 0, the price would be $24. So let's graph that. So quantity of 0, price would be $24 up here. All right, so there's 1 point on our demand curve. And then the slope is minus 3, because that minus 3 multiplied by Q. And remember, slope means rise over run. And rise means change on the y-axis, or change in price here. Run means change in quantity. And if that's minus 3, we can think about that as minus 3 over 1. And that means what this line's going to do is go down 3, 1, 2, 3, and over 1. Down 3 over 1, down 3 over 1. However, if you're more comfortable plotting a line by coming up with some points, by plugging in some quantities and getting some prices, you can do that too. You could plug in a quantity of 5, for example, into 24 minus 3Q and say, well, 24 minus 3 times 5 would be 24 minus 15, or 9. And that would give us another point. Quantity 5, price 9. Just make sure you can do this very carefully, very quickly, and very accurately. So get your index card or your ruler, and let's connect those dots very carefully. All right, so there's our demand curve. Now let's plot our supply curve here. Supply, 3 plus 0.5Q. So starting just like we did before, our y-intercept is 3. If the quantity is 0, P equals 3. And this slope of 0.5, or 1/2, it tells us that when we graph this, we can go up 1 over 2, up 1 over 2. So up 1 over 2, up 1 over 2. Or we could plug in some value like we did before. And we could say, well, just pick any Q, 10, whatever, right? Why 10? Why not 10? So if we plug in 10 here, P equals 3 plus half of 10. Half of 10 is 5. That tells us the price would be 8. So quantity 10, price would be 8. Here's another point for our graph. Quantity 10, price 8. And all these points need to line up on a perfectly straight line. So take your ruler, index card, whatever you're using as a straight edge, and let's graph this line. And there's our supply curve. So we've graphed these two equations. Now, the first thing we want to do when we graph demand and supply is we want to find what is the equilibrium price and what is the equilibrium quantity. And zooming in here, it looks like the equilibrium price is $6 right here. And the equilibrium quantity is 6 units. So from our story, this is where we were talking about the price of cookies is $6 and the quantity of cookies is 6 units that people are buying. However, we want to double check this because you're going to make mistakes every once in a while when you're graphing. But if the mathematics and the graph both agree with what's going on, it gives you confidence that you're doing things correctly. So let's double check this. So to solve these two equations, since P equals 24 minus 3Q, and P also equals 3 plus 0.5Q, we can set those two equal. And then we can subtract 3 from both sides. You get 21 on this side, and that 3 will cancel over there. And then we can add 3Q to both sides. So if we add the 3Q on the left side to cancel it to the 0.5Q on the right, we're going to get 3.5Q. So 21 equals 3.5Q. Divide both sides by 3.5. And 21 divided by 3.5 equals 6. So this verifies that what we're seeing on the graph is right. And then we want to verify that the price is right as well. And to do this, we can plug that Q equals 6 into either one of these original equations, whichever one seems easier. I think this one, the supply curve, seems a little easier. 3 plus a half of 6 is 6. So let's calculate and label on this graph the total revenue. So when we're looking graphically at total revenue, we know the formula for total revenue is price times quantity. Well, we know the price here is $6, and we know the quantity is 6 units. And when we want to put that on a graph so that we can see it easily, what we want to do is draw this little rectangle here over to 6 units and up to $6. And this green rectangle is going to represent the money that this business is getting when it sells 6 units for $6. Now let's think about why that's true. Well, first, the formula price times quantity is the same as the area of this rectangle. The formula for the area of a rectangle is base times height. And so here we see the base is 6 and the height is 6. 6 times 6 is $36, right? So $6 times 6 units equals $36. That's pretty straightforward. Another way to think about why this is the total revenue is each of these little boxes here. Think of those as $1. And if we count up the boxes, we get $36. And yet another way to think about this, just helping you learn how to visualize where these numbers are coming from, is that we can think about this $6 right here, right? These 6 $1 bills as being the $6 we get for selling the first unit. And then here's the $6 we get for selling the second unit, and the $6 we get for selling the third. We're just adding up $6 6 times when we're calculating the area of that big rectangle, right? All right, so we've labeled the total revenue with that green rectangle there. Now let's calculate and label the total benefit to the consumer. Remember what we were talking about in Chapter 3 when we were talking about the demand curve. Each point on this demand curve tells us what's the most this person would be willing to pay for each additional unit. So we call this demand curve, in addition to a demand curve, we call it the marginal benefit line. So we see here that this person is willing to pay $21 for the first unit, at most 18 for the second, 15 for the third, and 12 for the fourth, etc. So what we want to do to get the total benefit, not just what are you willing to pay for each additional unit, but what's the total most you'd be willing to pay for all 6 units, what we want to do is calculate the area of this entire shape that's under the demand curve. So this entire pink thing here is what we'd call our total benefit. So in order to get this total benefit, what we're going to have to do is calculate the area of a trapezoid here. Now, there is a formula for the area of a trapezoid. I don't know it because I think it's not something that you should waste your memorization powers. Instead, what we can always do with a trapezoid is we can divide it into shapes like triangles and squares that we already know how to find the area. But again, what we're trying to do is add up all the area under the demand curve and over to 6 units, since we're talking about buying 6 units. So in order to do this, what we can do is divide this shape up into 2 different shapes. We can divide it into a triangle up top here. And what's the formula for the area of a triangle? Well, the formula for the area of a triangle is 1/2 times the base times the height. And what we'll need to do is take that area of that triangle and then add it to the area of the rectangle on the bottom. But we already know the area of that rectangle on the bottom. That's total revenue. So let's focus on the yellow triangle. What's the base? Let's see. Well, it starts over here at 6 and goes down to 0. So 1, 2, 3, 4, 5, 6. All right, so that area is going to be 1/2 times 6 times, how high is this triangle? Well, it goes from 24 down to $6. 24 minus 6 is 18. Or if you really wanted to double check, you could just count your way up here, right? 1, 2, 3, 4, 5, all the way up. 1/2 times 6 times 18 is the same as 3 times 18. $54. All right, so the yellow triangle is $54 plus the total revenue is 36. 54 plus 36. The total area under the demand curve is $90. And that is the total benefit to the consumer, $90. And remember what that means. That's the most this person would be willing to pay to get the 6 boxes of cookies. All right, now, next question says, let's calculate and label the consumer surplus. Well, let's go back to our story. In our story about cookies, let's see, the $90 was the total benefit, the most we're willing to pay. $36 is the total revenue. The difference between the $90 in total benefit and the total revenue is consumer surplus. Hey, wait a minute. I think I see where that consumer surplus has to be on our graph. Since the total area under the demand curve is the $90 in total benefit, and the green rectangle down here is the total revenue, then that means that this triangle up top here is the consumer's surplus of $54 that we just calculated a second ago. So the total revenue down here is 36, and the consumer surplus is 54. for a total of 90, the total benefit, the most this consumer was willing to pay. So let's label that there. $54 in consumer surplus, which we calculated as 1/2 times the base times the height. All right, the next question asks us to find the variable costs for this business. So we want to know how much are they spending in labor and materials costs to produce the 6 boxes of cookies. A supply curve, in addition to telling us the quantity people want to sell at each price, the reason why people want to sell that many at each price is the supply curve tells us the marginal cost, the additional cost of producing each additional box of cookies. So in order to get the variable costs, the total amount spent in things that cost you more when you produce more units, what we want to do is find the area under the supply curve here. Now we have another trapezoid here. And for a trapezoid, you can always split it into 2 parts and add those up. So here's a little purple line to divide that. Let's zoom in so we can see this very carefully, what we're looking at. So this trapezoid, this orange shape, is a rectangle on the bottom, which is 3 high times 6 wide. 3 times 6 is 18. There's also this little triangular part on the top, which is 1/2 base times height. 1/2 times the base is this 6 down here, right? Times 6 times the height is 1, 2, 3. It goes from 3 up to 6. 1/2 times 6 times 3 is 9. So if we take this $18 in variable costs and this $9 in variable costs, that whole thing adds up to the total variable costs. Variable costs, $27. $27. Okay, the next thing we need to calculate here is the producer surplus. Now remember from our story, producer surplus is the difference between the total revenue that we have here in number 3, the $36, and the variable costs. So it's $36 minus 27. Can you see in the diagram where that producer surplus has to be? Remember, the green is the total revenue of 36. The variable cost is the 27 down here. So the producer surplus is this amount right here. It's this little triangle on top. So you can always find the variable costs as the area below the supply curve. The producer surplus is always below the price the business gets, the $6 each, and the supply curve. And the consumer surplus is always below the demand curve and above that price the consumers are paying. So this producer surplus is that little triangle there. 1/2 times this leg of the triangle is 3. 1, 2, 3. And this leg of the triangle is 1, 2, 3, 4, 5, 6. 1/2 times 3 times 6 is $9. Now we could have gotten that by using our relationship that we know, that total revenue minus variable costs equals producer surplus. We can calculate it both ways. Again, we want to be able to double check these things. All right, the next question says, let's calculate and label the total surplus. Total surplus just means we want to add up the producer surplus we just calculated of $9 and add to it the consumer surplus that we calculated earlier of $54. So $9 plus $54 equals $63 in total surplus. Now, why do we care about total surplus? As we talked about before, consumer surplus is one way to measure the well-being of consumers. How well off are they doing in this market? And producer surplus is a way of measuring how much money the business has left over after paying their variable costs. And then after they pay their fixed costs, they could have some profit. Producer surplus is not the same as profit, but the bigger it is, The bigger producer surplus is, the bigger their profit is going to be, because their fixed costs aren't changing as they produce more or produce less. So the bigger producer surplus is, the happier businesses are. The bigger consumer surplus is, the happier consumers are going to be. So the larger the total surplus is, it gives us an indication of total well-being in the market for consumers and producers both. And this is the thing that we care about as economists. Producers are people too. Consumers are people. So adding up this total surplus is a way to track how well off are people doing in this market. Now, I'll give you another way to think about it in just a minute. But let's go back up to our graph and let's see where that total surplus is, just to visualize it. So remember that consumer surplus is the big yellow triangle here. I'm going to erase the yellow here. And that producer surplus down there, let's just shade in that triangle, the large triangle that is the total of consumer and producer surplus. So we can visualize where this thing is that we're talking about here. Total surplus is all of that. Now, why do we care? Well, let me give you another name sometimes that economists will use for this thing we're calling total surplus here. Total surplus is also sometimes what we call the gains from trade or the gains from voluntary exchange. So total surplus, gains from exchange, or gains from voluntary trade. Well, why would we call this that? Well, let's look at this a little more closely, what this orange triangle is doing. So what's happening in this market is we're exchanging 6 units of cookies, 6 boxes of cookies. And let's look at that first box of cookies. This person is willing to pay up to $21 for that box of cookies. The business would be willing to sell it for, it looks like about $3.50 here. What's the gain from trade? Well, the gain from trade is the fact that I value the cookies $21. The business, it only cost them about $3.50 to make it. So this distance here is that total surplus. Some of it goes to the consumer, some of it goes to the producer. The second box of cookies, the consumer is willing to pay up to $18. It only costs the producer $4 to make it. So there's a gain from trade to be had here of that amount of money, 18 minus 4, or about 14. And same thing for the third box of cookies, and the fourth, and the fifth. And well, there's not really any surplus made for the sixth box of cookies, but here's the other interesting thing, that it's not just the first, second, third, fourth, fifth, and sixth box of cookies, because most of the time when we're looking at a market, these aren't individual boxes of cookies we're talking about. These might be thousands of boxes or millions of boxes of cookies. So there's also surplus to be had for the first box of cookies, right? Way over here, and the 1,000th box of cookies, and the 1,500th box of cookies, and the 2,358th box of cookies, etc. So what we really want to get is this entire area, the entire orange area there, is the quickest, easiest, and most accurate way to add up all of those surpluses that are being generated anytime someone buys a box of cookies that they value more than what it actually costs the business to make. Because this marginal cost, in addition to being the additional cost the business has to pay to produce it, is also what we call the minimum the business would be willing to accept in exchange for selling that box of cookies. The minimum WTA, or willingness to accept. So by adding up that entire area, we get this total surplus, which is a great thing because it's a way of measuring how much benefit everyone in society is getting from giving people things that have a high benefit. That's the demand curve, tells us the benefit, for a low additional cost. That's the marginal cost or supply curve here. Okay? This total surplus is the important thing that economists keep their eyes on. We want that total surplus to be as large as possible, because anything that reduces the gains from trade is going to end up hurting someone, either consumers or producers, or perhaps both. All right, so let's go and look at this last question here. What's deadweight loss? Deadweight loss is what we call it anytime something interferes with the market and we are not able to get to the efficient point, which in this case we're assuming is the equilibrium. The equilibrium isn't always the best point, but in this case, let's assume it is. So deadweight loss is when we can't get the largest total surplus possible. In other words, for some reason we can't get this $63. In this case, let's assume we could not get to that equilibrium. Suppose the government thought we only needed 3. My version still says CDs here. We're talking about boxes of cookies. So suppose the government said, hey, Dr. Berkey, you're too fat. You don't need 6 boxes of cookies. We're only going to let you buy 3 boxes of cookies. Let's look at what would happen in that case. They're putting a cap on the number that I'm allowed to buy. In other words, they're not allowing the consumer and the producer to engage in voluntary exchange as much as we would like to. We're not able to get the total amount of consumer and producer surplus that we used to. They're cutting us off right here at 3. So let's draw a line straight up at 3 units. And this might be what we call a production quota or a purchase quota. It's a limit on how much we're allowed to buy or how much we're allowed to produce. Now remember that total surplus triangle that we had before. That total surplus used to be all of this consumer and producer surplus. But now we're not able to get surplus for the 4th or the 5th or the 6th box of cookies. Or in a real situation, this would be anything past the 3,000th or 3 millionth box of cookies is going to be cut off. So what's going to happen to that total surplus? Well, it's going to be smaller, and the amount of surplus we're going to lose is going to be all this total surplus over here that we can't get anymore. And so the area of this triangle right over here is going to be total surplus that cannot be generated because we're not allowed to buy and sell those last few units. So that lost surplus is what we call deadweight loss. How much deadweight loss would be created here? Well, it's going to be the area of this triangle that I outlined in black. How big is it going to be? Well, this triangle, the area of a triangle is always 1/2 base times height. I like to think about the base as being this part of the triangle. And we just count up how long is the base of that triangle. Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half. It goes to $4.50 there. And the height of the triangle is from the bottom to the highest point. 1, 2, 3. So that lost surplus is going to be 1/2 times 10.5 times 3. So it looks like that deadweight loss is going to be $15.75. What would be happening here is instead of our total surplus being able to be $63, now the total surplus would be $63 minus that $15.75. So the total surplus would be 63 minus 15.75, or $47.25. And what deadweight loss really means is how much total surplus we are losing as a society because something inefficient is going on. In this case, we're not allowed to make those voluntary trades. So after watching this video, What you need to do very, very quickly, if you're going to understand this, is you need to try to do exactly what we just did by yourself. On your handout that you need to print out, here is a practice scenario where we have demand and supply equations. You need to graph them, solve them, calculate all of these things we just did, and then make sure that you can explain what all of these numbers mean. And the last page of your handout has some explanations, like we talked about, of what these numbers mean. So on the test, this is going to be your essay part of the test. Different equations, slightly different scenarios, but I'm going to be expecting you to graph demand and supply, calculate all these things, and explain what they mean. We're going to practice this some more with some other scenarios. Make sure you practice doing this. I'm going to post answers to this practice section on Blackboard so that you can check yourself. If you have any questions, let me know. This is Dr. Berkey signing out. I wish you the best of luck.